Hi guys, this is my 8.3 lab. Going off with what the professor gave us, basically data is a type that we don't specify until runtime. Node is going to just be, next is just a node. So down in the remove method, which is the first one he wants us to work on, we basically have if the head is empty, it returns empty. And that's going to basically be also for if the linked list itself is empty, the head would also be empty, so that's also returning null. Down in here, this if k equals 0 basically checks so that um, if k equals 0, that's going to be the 0 element. We've reached the element we desire for this remove method. So let's say k is 2. So each time we go through this method, it's going to decrease k by 1. So on the third, basically, time going through this method, that's going to be returning head.next, and which is the one we want to remove, which is the element we want to remove from the list. So down here, this is the recursion part. So it sets head.next to be equal to this method. And then it's passing head.next into the method and then doing that k minus 1 part. So it just goes through every time and it decreases k and sets the head to be the next head over. So we're moving along one element at a time each time you go through this method. And then it returns head, which is on the third time around, it's going to be every time it's getting updated right here. So on the third time around, it's going to be the third. So for the example, in test, so when we're doing this remove here, we want to take the third one out. We know that this is our list. So the third element is that 1 right there. So we're going to go through once. 3 is not equal to 0. So we go through again, and we've taken it down. So 2 is not equal to 0. Well, at this point, we're here. And then 1 is not equal to 0. So we're right here on the 2. And then 0 equals 0. And that is that one. And that's the element we're going to take out of the string. Out of the list, I mean. And that's how that remove method works. Down here in the push method, it just gets the head node and then the new data we want to push into the list. And it just creates a new node with the node head of the current list, and new data is the new data that we want to pass in. So it kind of just creates a new one and then like kind of just adds on to the uh, old list. So for string here, toString, we set if the head is empty, it returns just this like an empty string. And that's also for the end of the list. The head would be null in that case. And then if head.next is also null, we return the whole thing plus an empty the last element. And then for the return, this is the normal one where you're like at the beginning or in the middle. It's adding that space there and then converting head.next to be a string and adding it to head.data. So I did have issues with this one because it kept getting the trail like it kept getting like a tail end and like a space at the beginning as well. That was happening for a bit, but in the expected equals, it doesn't want any trailing space or beginning space, which is kind of weird because here in the instructions it says end with a trailing space, so it's kind of confusing. I'm not sure, but just if I'm just doing what his test class is doing, you don't want a trailing space, I guess. So that's basically all I have for the code. If we run it, it's going to give this right here, so it worked. I also added this guy, just like you can use to check. We don't really need him anymore though, just to check if the what it is. So when we run it, it will like print out the list. Yeah, right there. Just for debugging, if you need it, you can do that. Basically, so from what I can tell, going over the other points, he is asking us for the advantages of using is just like code readability. It's like pretty easy to set up recursion sometimes, and you can just, if you have like a smaller like list, or if you have code that you want to, like a smaller code that's easy to like just compartmentalize and make, it's easy to read, you're not going to have as many errors. um, but I guess the main disadvantages is like memory use, because you do have to go through like over and over and over again, while iteration can some like usually be better if you comparatively to recursion for memory and time usage. Like recursion is probably going to be slower in almost every case. But I guess for certain things that are like just naturally like recursive, like in the um, in the notes he was explaining how what is it, factorials and fractals. Those are both things you want to use. Um, you want to use recursion for instead of like iteration. Let's see, the linked lists are basically just nodes that work in like a chain. The first node in is the head. Well, the first node is the head. That's like, I guess, the last one in this case. Um, and in order to access all the rest of things in that linked list, you have to start at the head. Um, so it's very, from the advantages, I guess, so it's very easy to change the size of. As you can see, like we can just keep adding to it, keep taking things off if we wanted to, and it updates like immediately. I think that it's faster than an array when it comes to like adding and removing. But I guess the disadvantages are if you're doing like a more random access, like in the middle of the linked list, it takes longer to access and like remove things. T template we used, that's uh, over here. That's basically so we can give it kind of any data type, a string, an integer, um, your custom classes, anything like that, and uh, it just holds it, and then it only basically assigns them at runtime. So it's has that advantage, so that you don't have like the compile errors as much, and it would be more like a runtime error that you could manage if they gave it something that's just not compatible. And then I guess as far as like making things better for this code, you could use like a string builder down here, I think, um, and that would probably reduce the number of like time it would take, so you wouldn't like have to do this toString every time. So then, yeah, I guess you could like build it all at once. And then also another thing would just be like adding more like error handling during runtime and stuff like that. But that's all I have. Thank you.